When the New Horizons probe approached Pluto, it left us stunned. We thought it was a dead star, but it turned out to be an active world full of surprises, mountains and valleys, an atmosphere and something similar to methane snow. But that's not all. New research has discovered something surprising that we didn't expect, and that will be talked about in the coming years. Perhaps what we've been looking for a long time is right here. Pluto has undergone great transformations in its history, but the most amazing thing is that it will transform again as soon as it approaches the Sun in its orbit. This great discovery changes everything and makes us think that much of what we know about Pluto is wrong. Many scientists are trying to give an explanation to all this, which is inconceivable by its nature. But not only are we going to see this, but in this video I will show real photos of Pluto, some of them unpublished, and we will also reveal its deepest secrets. What you will see is impressive and rewrites the history of Pluto. In 2006, a powerful Atlas V rocket propelled the New Horizons probe to one of its highest speeds to date, 588,000 kilometers per hour. This allowed it to rapidly approach Jupiter in 2007 and gain speed thanks to its gravitational field, up to 84,000 kilometers per hour. After a 9-year journey, New Horizons encountered Pluto in 2015. During a flyby, it did not enter orbit around Pluto due to the high speed of the craft and the lack of sufficient fuel to perform such a complex braking maneuver. It quickly passed within a minimum distance of approximately 12,500 kilometers of Pluto's surface. Even traveling at 14 kilometers per second, the probe was able to photograph Pluto for 9 days. What it found was fascinating, a diverse and active surface. New Horizons revealed that Pluto has a complex geology with mountains, glaciers and a vast frozen plain called Sputnik Planitia. These findings suggest that Pluto has an active geological history. The probe also detected a thin atmosphere, composed mainly of nitrogen, with traces of methane and carbon monoxide, which extends more than 1,600 kilometers above the surface, although 100,000 times less dense than Earth's. But the most intriguing thing is the existence of a renewal mechanism, as if it had a heat source inside it that allows it to have some tectonic activity. In addition, the fractures in the Sputnik Planitia plain and its young surface suggest that beneath its frozen crust there is an ocean that is kept in a liquid state by heat. The existence of an underground ocean is a hypothesis supported by geological models and indirect observations. But how is this possible? Pluto is smaller than the Moon and is more than 5.9 billion kilometers from the Sun. It is possible that Pluto was habitable in the past and still has some form of life today. Pluto contains water, ice, and organic compounds, the building blocks of life. Scientists began to think that it was not likely that Pluto formed on its own in the Kuiper Belt, but that its origin could have been completely different than we thought. This new study changes many things. Possible origin of Pluto. When scientists analyzed the computer model of once habitable Pluto, they were stumped. Everything fit. Pluto formed 4.6 billion years ago and may have once been closer to the Sun. The NICE model is a set of theories about the formation and early evolution of the solar system. It suggests that the giant planets migrated significantly from their original positions. This migration would have affected many smaller bodies, including Pluto, shifting it from an orbit closer to the Sun to its current position in the Kuiper Belt. We have to assume that all the planets, including Pluto, formed from a protoplanetary disk, a giant cloud of gas and dust that orbited the young Sun. In this cosmic dance, Pluto formed much closer to the Sun than it is today. This tiny world was once more than twice as big as it is now, and like Earth and other worlds, it contained a lot of water. Thanks to the presence of volatile ices in the protoplanetary disk, in addition to the bombardment of comets forming its crust, at the same time, the disintegration of radioactive elements in its core, they could have generated heat and formed an ocean of liquid water under its surface. This ocean would remain stable thanks to the generation of internal heat. In addition, in this theoretical model, the atmosphere was about 40 times denser than that of Mars, which means that clouds could even appear. A young planet almost 6,000 kilometers in diameter, and with an almost circular orbit, Pluto seemed the ideal place for life to thrive. Life as we know it needs time to evolve, but that was about to change. The planets Jupiter, Saturn, Uranus, and Neptune, the gas giants, formed closer to the Sun and then exchanged positions, moving outwards. On its journey, Neptune dragged Pluto with it towards the outskirts of the solar system. Pluto began to cool, forming a layer of ice on its surface, but retained its liquid ocean thanks to the heat inside. But during that migration, something happened that would change Pluto forever. One theory suggests that approximately 4.5 billion years ago, a sizable Kuiper Belt object, perhaps half the size of Pluto, impacted Pluto at high speed. The collision was powerful enough to vaporize part of both bodies and release a large amount of material into space. This debris dispersed around Pluto, forming a disk of debris. Over time, the debris in this disk began to clump together under the influence of gravity and form a Charon. This accretion process gave rise to its main satellite that we know today. The existence of Charon as a relatively large moon compared to Pluto, and the presence of other smaller satellites in the Pluto system, suggests that this collision event generated multiple fragments and satellites: Styx, Nix, Cerberus, and Hydra. Pluto lost part of its matter, but in that collision, Charon left a heart on its surface, the so-called Tomboa Regio. Since then, Charon and Pluto have never separated and have moved away together to the confines of the Kuiper Belt. At the same time, the interaction with other bodies was changing Pluto's orbit to a more elliptical one with extreme changes in temperature. The wounded Pluto was gradually losing its atmosphere, becoming a less active and colder world, on its way to becoming a dead world like our moon. But its satellite Charon did not allow it, and the reason is because Charon is very close to Pluto, which caused great gravitational tensions that allowed Pluto to still retain its internal heat from its formation and to have some geological activity. Discoveries of New Horizons. This is how New Horizons saw it, which provided detailed images of Charon. These images show geological features that support the hypothesis of a formation from debris of a massive impact. In addition, Pluto's inclination is about 120 degrees, compared to our planet's 23 degrees, which again supports the impact hypothesis. This causes Pluto to have large atmospheric changes in its orbit around the Sun, with long seasons of more than 60 Earth years. Pluto takes 248 years to complete an orbit around the Sun, which means that each season lasts approximately a quarter of that time. Regarding the heart of Pluto, it is 1,590 kilometers long from east to west, and represents the mark of the impact, and its fate linked to Charon. It appears as a vast white plain, a vast glacier of frozen nitrogen gleaming in the pale sunlight, but what supports the presence of the great ocean on Pluto is that Charon is mostly covered in water ice. In the Big Impact, Pluto ejected a large amount of water ice. With a significantly lower mass, Charon was unable to retain volatile compounds such as nitrogen and methane. Instead, Charon has a higher proportion of water ice that is less volatile and more stable. It can be said that Charon has part of Pluto's ocean in the form of ice. However, this is not the only evidence. New Horizon revealed that Pluto has gigantic mountains, some of which rise to more than 3,500 m high. Cryovolcanoes such as Wright Mons and Picard Mons stand out. In March 2022, a team of scientists thought that the mountains Wright Mons and Picard Mons are a fusion of several cryovolcanoes. Images and data from NASA's New Horizons mission show areas with textures and compositions that suggest the presence of icy volcanic materials. These areas have characteristics that resemble those of cryovolcanoes observed on other bodies in the solar system, such as Triton, a moon of Neptune. Cryovolcanism on Pluto may be driven by residual heat, generated by the integration of radioactive elements in its core. This heat can melt internal ices, allowing liquid materials to be expelled to the surface, just as Earth does with volcanoes. But these volcanoes do not expel magma, but water and nitrogen ice, and this tells us once again that Pluto has a large heat retention in its interior and a liquid ocean. A water ocean? This cryovolcanic activity is certainly one of the most surprising discoveries of the New Horizons mission. And if NASA were to take samples of that water ice or the surface of Charon, we might make an even more astonishing discovery. After all, no one understands Pluto's geological activity. What's more, a NASA team has discovered that the reddish material covering part of the dwarf planet is organic matter, molecules formed from the interaction of methane and nitrogen under the influence of solar radiation and energetic particles. This means that Pluto should have a chemically active ocean, and that organic molecules could form within it. Although this idea is still under investigation, when there is liquid water and organic compounds, there is a good chance that DNA and RNA chains, the building blocks of life, could form, and we know that these chemical precursors can arise in unexpected environments. Pluto, despite being a distant and small world compared to the inner planets, is home to a variety of fascinating geological features. In the region known as Tartarus Dorsa, there are impressive mountain ranges that seem to float above the surface of Pluto. These mountains are composed mainly of frozen water and other volatile compounds. Pluto shows areas with chaotic and fractured terrain, such as in the Cthulhu Macula region, which extends approximately 2,990 kilometers. These areas suggest past geological activity, possibly caused by the contraction of the crust or by cryovolcanic processes. The curious thing is that these geological accidents are found in orb bodies of the solar system, such as Jupiter's moon Europa, or in Triton, Neptune's moon, which are closer to the Sun. This fracturing indicates that there is internal tension and suggests internal warming. In this photograph taken by New Horizons, we observe the highest mountain on Pluto, called Picard Mons, and has an altitude of approximately 7 kilometers. It is actually a cryovolcano with an extension of about 250 kilometers. This giant cryovolcano spews water and nitrogen ice in a semi-fluid, cream-like state. Pluto's largest cryovolcano is very similar to the tallest volcano on Earth, Hawaii's Mauna Loa, and scientists say the last eruption occurred very recently in geological terms, about 10 million years ago, but this could change in the future. This is certainly not the only unexpected discovery on Pluto. NASA scientists have analyzed some curious cells in the Sputnik Planitia Basin. These curious structures, tens of kilometers wide, are composed of methane, nitrogen and carbon monoxide ice and seem to rise about 50 meters and are separated by gorges 100 meters deep. The most interesting thing is that they move over time, similar to terrestrial glaciers, which once again shows the great internal activity on Pluto in the form of heat that raises part of the crust. The most interesting thing is that Pluto's orbit is so eccentric that it can vary by up to 3 billion kilometers around the Sun. Unlike Earth, which only experiences about 5 million kilometers of variation in its orbit, this is significant because it means that Pluto can warm up again when it gets closer to the Sun, and everything indicates that it will. Right now it is experiencing an icy period. Its atmosphere is condensing and freezing, but when it gets closer to the Sun in superhelium, many things can change. We have internal geological activity, cryovolcanoes, a lack of impact craters, which suggests geologically young surfaces, and that means that Pluto changes progressively over time. Currently, Pluto is about 5,245 billion kilometers from the Sun, which is an immense distance. But even so, solar radiation can change the surface and create ghostly structures. The ice mountains in Tambot Regio cause warming and evaporation of ice. This is important in the Cthulhu Regio mountain range of 2,990 kilometers in diameter, where methane evaporates and then falls from the mountain peaks in the form of frost. Without a doubt, Pluto is a fascinating laboratory with immense potential for life. But is this possible? Possibility of life? Pluto's surface is bathed in ultraviolet radiation. It has no magnetic field and the atmosphere is very thin. It is practically a vacuum. The lack of nutrients and radiation destroy DNA, and that makes the existence of any known organism highly unlikely. However, on Pluto there are geological formations called xolans or tholins, which are formed when ultraviolet light from the Sun breaks down methane and nitrogen, generating this particular compound in a reddish color with a texture similar to tar. The term Zolens was mentioned by astronomer Carl Sagan and his colleague Bis Hunkerer in their Miller and Urey-type experiments to describe primitive organic molecules. In the Miller and Urey experiment in 1953, they created a closed environment with essential elements for life, such as water, methane, ammonia and other compounds, simulating the atmosphere of the primitive Earth. They applied electric shocks to activate chemical reactions. What they got was not life, but Zolens, disordered molecules that are precursors of life, which are similar to the tholins found on other bodies in the solar system, such as Pluto. This means that if Pluto had a dense atmosphere, a magnetic field and was closer to the Sun, it would have an immense potential for life, and this may be possible in the future. In the year 2217, Pluto will be closer to the Sun again, and we believe that it will experience global warming. If part of its current ocean is frozen, it is possible that it will become liquid and the surface will contract, since we know that ice causes an expansion effect, and we are seeing this on the surface in its current period of global cooling. If you see these photographs, the crust seems to swell. Hypothetical ecosystem. What kind of life can exist in a liquid ocean protected from radiation? Microorganisms adapted to extreme conditions. This could include psychrophilic bacteria, adapted to low temperatures, extremophile archaea, or even life forms based on alternative biochemistries to those known on Earth. Hydrothermal activity driven by internal heat on Pluto is the ideal place for the formation of complex molecules. Organisms could obtain energy by oxidizing chemical compounds available in the environment, or forming symbiosis with other microorganisms. But as has happened in the past, Pluto could change its orbit again in the future and be a habitable planet, or have life forms on its surface. What is certain is that additional heat from the Sun could thaw the ice on Pluto's surface, forming oceans or lakes of these compounds in a liquid state. It would be a very interesting surface but lethal for us. Even if it were the same distance from Earth, it is unlikely that Pluto would form a dense atmosphere, due to its small size. Take our Moon, for example. It is the same distance from the Sun as the Earth, but there is no atmosphere and no life on it. Gases such as methane, nitrogen and carbon monoxide are harmful to life as we know them. Without a magnetic field or an ozone layer, there is virtually no chance for complex life forms such as plants and animals to develop on Pluto, either now or in the distant future. But simple organisms could exist in a protected liquid ocean. We leave fascinating Pluto behind and realize that the cosmos still contains great secrets, strange chemistry, and a great history. This makes us understand the great cosmic diversity. We are witnesses to the wonderful machinery of life. A special phenomenon arising from evolutionary processes spanning billions of years, and in every corner of the universe, on far-off planets and distant moons, we find the same elements and conditions that allowed our existence, scattered and disordered, but it is possible that those same elements may have come together again in countless worlds, giving rise to a great variety of landscapes and life forms that we cannot even imagine. Hush.